Okay, and before we get started, just a friendly reminder to join the CHOP R user group. We would strongly encourage you to join if you haven't already. This is also open to people at Penn, so it's not exclusive to CHOP. This group has more than 400 members from all departments and is a great place to network with other R users or get help with coding problems and learn about new packages, webinars, and conferences. We also offer workshops like this one and have semi-regular meetings as well. Another announcement, in case you're interested, we would welcome you to come to our office hours. So these office hours are regularly available and a great way to get help with R. We currently offer two kinds of appointments: one-on-ones if you would like individual help, or open appointments that are more of a community conversation about whatever R questions people bring up that day. The open appointments can be particularly valuable to attend if you want to hear other people's questions about R and you maybe don't have a specific project that you need to troubleshoot. And also here we'll give a little call for potential volunteers. So if you are like the idea of our office hours and you yourself are an experienced R user, feel free to join us and volunteer to help set up appointments. And if this is something that is interesting to you, you can feel free to reach out to myself. My name's Alexis, or you can also reach out to Rose. Her email is here as well. And another kind of brief announcement that we wanted to put out there, R Medicine is currently accepting abstracts for their upcoming conference in June. Abstracts can be on a variety of topics, but they should use R-based tools. More information, if you're interested, is available at this link. Okay, and our last announcement before getting started, again, just a reminder that this is the second talk in a new series called R102, Mastering the Fundamentals. And so next month, we'll have the third talk in the series, which will be reshaping data with tidyr. And now these workshops are intended as a continuation of the popular Intro to R for Clinical Data workshop that is offered a few times a year. And these talks are generally designed with beginners in mind. So if you're trying to figure out how to get started with R or how to start applying R in your own work, these talks are ideally geared for you. And to see the schedule of the talks or learn more, feel free to check out the website here for more details. Okay. And so now we can kind of move on and get started with our actual talk for the day, which is summary statistics. And so this talk is going to be a quick dip into some 102 level R. So ideally, if you've had a little bit of exposure to R before, maybe through the Intro to R Clinical Data workshop, this would hopefully be the right level for you now. If you're completely brand new to R, no problem, welcome. You may find it a little tricky to actively follow along with the code today, but go ahead and give it a try. Or if you'd rather just listen, that's also a totally viable option for today. And so our topic is going to be getting summary statistics in R, which of course is really one of the first steps to pretty much any analysis. And we're also going to look at how to present those summary statistics in a lovely publication-ready Table 1. And if you have any questions or challenges throughout the talk, feel free to put questions in the chat. We have a few additional team members who will try to answer your questions during the talk. And if there's extra time, we can also stop and try to talk about things as a group. Okay, so just a brief summary of what we're covering today. Definitely we want to talk about how to get summary statistics in R for both continuous and categorical variables, how to create a publication-ready Table 1, and just a reminder that we're not teaching the full analysis pipeline. We're just going to be glossing over importing data and tidying data for now. And we're not teaching formal statistical modeling or hypothesis testing. Okay. So summary statistics, also called descriptive statistics, serve a few important functions. They help us understand our data better during exploratory data analysis. And this can be really helpful to catch errors or outliers in your data. They also give us an idea of what our study population was like at baseline. And this is really helpful because it has implications for how generalizable your results might be. And summary statistics can also help us identify or show pre-existing differences between groups. So this could be important if we want to be interpreting, differences potentially after a treatment or some sort of intervention. So which statistics should we consider? For categorical variables, summary statistics are generally limited to counts in each category. For example, how many patients tested positive and negative for a particular condition. For continuous variables, there are a lot more options. Summary statistics generally focus on central tendency and variability. In other words, where on the scale are the data located and how spread out are the data. For example, consider a variable like age. A measure of central tendency would tell you generally how old are the research subjects. Is this a pediatric population or adult? Examples of statistics that capture central tendency are the mean and the median. And so let's say, for example, the mean age was 45. Now you have an idea of where on the scale we are, right? This is not a population of children, nor is it a study about advanced age. Another question we might be interested in is the variability, or how spread out are the data. So this could be a population sampled from across the lifespan, with participants ranging from 5 to 90, or it could be a more focused investigation of people in their middle ages. So examples of statistics that capture variability are variance, standard deviation, interquartile range, and range. So we won't get into all of the mathematical details of each of the statistics here, but if you'd like a refresher, feel free to check out these links. And you'll see that there'll be several of these sort of learn more slides throughout the presentation. These are a great resource to come back to afterwards, but we won't click through any of the resources right now. Okay, so now we're going to get ready to get started calculating summary statistics in R. Um, so by far the best way to learn R is to practice. So work through this code yourself as you follow along. There are going to be two options for you. So the first link here will take you to Posit Cloud, which gives you a way to work with the code right in your browser without having to install anything on your machine. You will need to create a free account if you haven't already done that. And I'll show that page in a second so people can see what it looks like. The other option is to get all of the code from our GitHub and download that directly onto your machine. And so this would be a good option if you already were really comfortable using R in RStudio on your personal machine. And then so if you want to go this route, you'll need to first go to the GitHub repository and then find the green code button. And then if you click on that, you'll see several options, one of which is to download a zip file. Okay, so I think let's just take a minute to make sure everybody is able to find the Posit Cloud link. So I'll just, or download the materials from GitHub. So if you, oops, let me see if I can resume this. So when you first, that first link, when you first click it, you should get a page like this. And then ideally you will be able to navigate to this R summary stats folder. And then there'll be a summary stats exercises file, and that's where we'll be starting today. Okay, if you have any questions, feel free to reach out in the chat. And I guess let me just also add, so once you open this exercises folder or files, just so everyone can find it, we'll be running the code. Much of the code is already preloaded here. So that's a good option. You can either just use the green arrow buttons here if you'd like to just run the code directly, or there's the option to type the code into the console if you would prefer to do that. Okay, we'll resume from here. Okay, so now that we kind of are ready to get started in R, we'll first load the packages that we'll be using today. So first we'll need to load the tidyverse packages, since we'll be using several functions that come in the tidyverse. We'll also load the medical data package, which includes several publicly available datasets with medical data. And then we'll also load the GT summary package for creating publication-ready tables. These packages all have excellent websites available with lots of great tutorials. So definitely feel free to come back and check out these websites to learn more. Okay, so the first step is to load the packages. And if you're running this on your own computer rather than in the cloud instance, you may need to run install packages first if you haven't ever used these packages before. If you're working in the cloud, all 3 packages have already been installed for you, so you won't need to do this first line of code. Then to load the packages, we'll want to run these library commands here, which are written out for you in the first chunk of the summary stats exercises file, like I showed earlier. So you can go ahead and make sure that file is open, and feel free to click the green arrows to run those lines. Okay. The data itself, to access that, the data we'll be looking at today, either in the console or in the exercises RMD file, run the following command, where it's just head of cytomegalovirus. So that code is also written out for you. Now, if we want to take a look at the data, when we run that command, we should see the first 6 rows of the data frame, which looks like this. And just to note that this is one of the example datasets that comes built in when you install the medical data package. So it's already available to you without having to read it in or download anything. And so those of us who have worked with R before, you know that importing data is a whole thing. So we're definitely skipping over a potentially tricky or challenging part by using built-in data. But for today's presentation, we really want to be able to focus as much as we can on the summary statistics. There's also a great option if you want to learn more about the data set. You can type this command starting with the question mark. And also just a kind of a nice feature of R, if you're somebody who is worried about typos or maybe thinking about copying this over and over, you can use tab completion for the data set name. So if you start typing CYT in the console, you should see that RStudio will sort of suggest the correct name for you. And then you can hit tab in order to fill that in. Okay, so you can see when we run this command, that will provide us some more information about the data set, about how there are 64 consecutive patients who underwent a specific cell transplant process. And the primary risk factor of interest in the study was the number of activating killer immunoglobulin-like receptors, or AKIRs. And if you're interested in learning even more about the data and the study behind it, we have a link to the article here. This is also a great place to learn more about the medical data package on its website. And also just to note that the maintainers of this package are always looking for data contributions. So if you have a data set that you think would be a good fit that's shareable, feel free to look into that further. Okay, so the first thing we're going to do is start by running the summary function on just the age column. And this is the code to do that here. So this summary function is one of the best places to start your exploratory data analysis. And you can use it on an individual column like we're doing here, or also on a whole data frame. So first, let's look at what we get from running summary on the age column. So we can see that the min is 29, the max is 67, which tells us, of course, that the youngest patient is 29 and the oldest is 67. It's also giving us some more information like the first quartile, the median, the mean, and the third quartile. We can also try running summary on the whole data frame at once using this command here. And when we do this, you should see a summary of each of the 26 variables in the data with the set of summary statistics printed under each. This is a great way to get a lot of information quickly. And the summary function is clever enough to print out different summary statistics for different variable types. So it won't try to calculate the mean or median of a categorical variable, which is called a factor in R, since that wouldn't be meaningful. The summary function checks what type of variable, numeric, categorical, or factor, etc., is in each column, and then returns sensible summary statistics for each. For a factor, you get the count for each level and also a count of how many observations are missing. For numeric variables, you get the range, which would be the minimum and the maximum, and then the first quartile, the median, the mean, the third quartile, and the count of the missing observations. In this data set, most of the data are numeric. There is one column, however, diagnosis, which shows up as a factor. Let me go back and make sure we can see that. Here. I'm sorry, that it's currently showing up as a character diagnosis. That's why we see it here. It just says class character. However, if we look at the help documentation for this data set, we'll see that diagnosis should actually be a factor variable with 13 levels. And if it was a factor, we would also be able to get more useful summary statistics as well. So one of the things we can do is convert the diagnosis column from character to factor using the code here. Then we can rerun the summaries for that column. And now we get counts for each type of diagnosis, which is much more informative. There are also in this data set a lot of variables that are represented in the data as 0 or 1, but should really be considered factors. And we're going to clean those up in the next step. So we could clean up those variables using individual commands like as.factor, just as we did for diagnosis. But instead, we'll take a look at a different approach. And also note that this code is in the summary stats file, so no need to try to copy it out now. Okay, and since this is a big chunk of code, we can try to break it down a little bit. So we're using the mutate function here to make changes to columns in the data frame. We can use mutate to create new columns, but in this case, we're just going to be overwriting existing columns. Within the mutate command, we have a different argument for each column we want to change. They all take the form column name equals factor, column name, levels, and then labels, where the levels are the existing values in the column, like for example, zeros and ones, and the labels are what we want them to show up as in the factor. For example, males and females and males, like this. It's important to note that the order of the levels and the labels must line up so that the first level will get the first label and the second level will get the second label and so on. And if you're interested in learning more about the factor command, feel free to check it out. You can check out its help documentation by typing $factor. Okay, also just a few other notes about that above code, since that was a big chunk. First is something called pipes. So you might be familiar with these if you've used R before, but there's some documentation here that goes into some more detail about the difference between using this particular pipe, between using the new pipe, I should say, and the original pipe. So these are the two different pipes here, this one and this one. There's also some documentation about comparing the new and the old pipes, and more information about the mutate and data transformation in general is available here as well. Okay, and also just a quick note about troubleshooting. So if you make a mistake modifying the data, how can we undo this? So if this was a data set we were reading in from an external file, maybe like a CSV, we know that we could just read it in a second time to get a fresh copy. But how do we get a fresh copy of a built-in data set? So one thing we can do is run RM. Let me see if I can pull it up here. is run this particular code here, RM cytomegalovirus, and this is going to reset the data to its original state. And this will delete our current version of the data from R's environment, and we'll just be left with the original clean copy from the medical data package. However, it's important to note that if we run this code and reset the data, we'll need to rerun any changes we made that we would like to keep. So things like converting diagnosis to a factor, that won't be preserved. We'll have to rerun our code to do that again. Okay, so let's go back to the summary function and run summary on the whole data frame again to see what it looks like now that we've cleaned up the column types. So we can see that the results are much more useful now that we've cleaned up the columns. So next we can move on to looking at some individual summary statistics. So for example, we might be interested in this question: what is the shortest time from diagnosis to transplant in the data? And so here's some code that could help us do that using the min function. However, if we try to run this, you might see that we get NA as a response. And this is because there is a missing observation somewhere in this column. And we can see this, and if we look into the help documentation for min using ?min, we can see that the default for this function and the default for many statistics functions in R is to use na.rm equals false, which basically means only compute a value if there are no missing observations. So if we want to kind of work around those missing values, we can rerun the min function, but be sure to set na.rm equals to true in your code. Also here we can point out that there's sort of a little shortcut. So if you're writing your code in the console and you want to make a small modification like this to the previous line of code, you can use the up arrow on your keyboard, and that will bring up the last command you ran. Then you can edit it and hit enter to rerun or run the tweaked version. So now when we run min, we should get a minimum value here. We can also similarly look at the longest time from diagnosis to transplant using the max function. And since these are all going to be run on the same column, you can use the up arrow again, and this time just change min to max. And then we can do similarly look at the mean time to transplant by changing max to mean. And we can look at more individual statistics like median, variance, and standard deviation. Okay, so next we're going to do the first coding challenge. So if you look in the summary stats exercises file, you'll see that there's the first coding challenge is around, I believe, line 89. And right now we'll take 2 minutes for everybody to work on that. So those 2 minutes are up, and I think for today, in the interest of time, we'll just keep going with the presentation, and then if we have time at the end, we'll take some time to review all of the coding challenges. But the solutions are also provided in that folder. So if we don't get to the solutions today, there'll be plenty of time afterwards to review, and feel free to come to our office hours or reach out to one of us today if you have questions about the answers. Okay, so now we're going to move on and talk about counts. So for categorical variables, summary statistics are really just counts. So we'll look at 2 ways to get counts for a single categorical variable in R. So we can use the summary function to get counts for factors, but it won't work on character vectors, whereas table will actually work to get counts on factors and characters. So here, this first line of code, summary, you can see that gives us some counts. And then table, we can also apply that. And we see that that also gives us counts. However, it's important to note that table doesn't give us any information about missing values by default. It just gives counts for observations with data. If you want to see missing values using table, we need to add the use NA equals always option, which is shown here. So if we add that option to our code, you'll see that we now additionally get the NA values. To get counts of two categorical variables together, for example, potentially you would be interested in the diagnosis type breakdown by recipient CMV status, we can use cross-tabulation, which is also called crosstabs or two-way frequency tables. So if we run this xtabs code here, you can see that that's going to give us a 2x2 table. One thing we can also do with this is we can get the results of a chi-square test on the crosstabs by applying the summary function to the crosstabs object. So option 1, there's some code here where you can nest the summary and xtabs functions together. Or you can save the xtabs object and then run summary on it. And I know we said that we weren't going to be doing any actual hypothesis testing, but you'll see here when we print out the results, we're actually doing a chi-square test of independence. And for today's talk, we won't get into interpreting the test, but we wanted to show this because you may recognize that here we're using the summary function again. And so the summary function is one of several functions in R that shows up in quite a wide range of different circumstances. And it's smart enough to give you different output depending on what you ask it to summarize. So just like it switched what kind of descriptive statistics it printed when we used it on a numeric or versus a factor variable, if you run summary on a crosstab, it prints out the relevant statistical test for that table. And if you're interested in learning more about kind of styling or printing out the crosstabs, feel free to see the table cross function in the GT summary package. Okay, next we'll give another opportunity for coding challenge number 2. And so this one is also located in the summary stats file. I believe it's around line 149. And we'll go ahead and take 2 minutes for people to try out this one as well. Okay, the 2 minutes is up. And so as for coding challenge 1, we'll come back to the solutions at the end of the talk if we have time. Okay, next we're going to move on and talk about presenting summary statistics in R. So many research articles begin with a table summarizing the patients or the research subjects analyzed, and that table is usually broken down by condition or exposure to allow the reader to see any differences, any potential baseline differences between groups. For example, here is a picture of a table 1 from the paper that this data set is from. And so one way to create a summary table would be to copy all of our summary stats from R into whatever program we are using to write our article. That process is both error-prone and tedious, and it also means that if anything changes in your data, you'll need to redo all of that work. So another approach is creating the whole table right in R, and the GT summary package is a great way to do this. So we're going to recreate an approximation of the cytomegalovirus table 1 using GT summary. And often a lot of the work that you need to do to get a table to look how you want it to look is actually data cleaning work rather than anything about the function that will create the table. And this example here is really no exception. Note that the table here breaks patients down by whether their AKIRs are 1 through 4 or 5 to 6. In the data, AKIRs are just numeric scores numbered 1 through 6. So first we'll need to create a factor for those two groups. Similarly, the table groups all patients with at least 4 prior chemo treatments as one group. Okay, so here we have some code for recoding variables for the table. And we can break this down a little bit. So first, we're going to be using the if_else function to recode the numeric variable, AKIRs, as one of two strings, either 5 to 6 AKIRs if it's greater than 4, or 1 to 4 AKIRs otherwise. This is going to result in a character vector called AKIR groups. And so in this next line, we are going to turn that character vector into a factor. Next, we're going to apply the same approach to the prior .chemo variable. First, we want to make everything greater than or equal to 4 into this kind of grouped greater than or equal to 4 group. And then we're going to set all other values to as.character based on whatever the prior values were. This changes the numbers into string versions so that a numeric 0 becomes a character 0, a numeric 1 becomes a character 1, etc. That's going to create a new variable called prior.chemo_groups, but it's going to be a character vector, which we'll also want to turn into a factor with the last line of code here. So if_else, this function, is what's called a ternary operator, and it has 3 parts. It has a conditional test, a value to use if the test returns true, and a value to use if the test returns false. So in the AKIRs example, we first tested each value to see if it was greater than 4. If yes, then we assigned it to the 5 to 6 AKIRs group. And if the answer was no, then we assigned it to the 1 to 4 AKIRs group. And it's important to note here that if_else, it preserves missing values. So anything that was NA in the original AKIRs variable, it will still be NA in this grouped variable. So if you're interested in learning more about mutate and the if_else function, feel free to see this link here for some more examples. Here we also want to point out to be really careful because there are 2 different functions that look very similar, and they do almost, but not exactly the same thing. And the 2 functions are if_else, the function we've been talking about, and then also this function if_else without the underscore. So if_else is part of the dplyr package, and if_else is part of base R. This can be a little bit confusing, and there are a few differences in how the 2 functions work. But one of the big and maybe most important differences is that if_else does not preserve missingness. So this is a really subtle difference, but it's something we want to be careful about. Okay, so now we can kind of take our first attempt at making table 1, and we can use that new AKIRs groups and the prior.chemo groups variables in our table. So here is some code here for creating the table 1, which we'll break down a little bit. So first, we're starting with our original data frame, and we're going to pipe that into a select command. And this is going to help us pick out just the variables that we want to use in our table. Then we're going to pipe the selected data frame to the table summary command. And we're going to put the argument by equals AKIRs groups to tell it that we want the table to present summary statistics for the 2 different categorical groups, 1 through 4 and 5 to 6, in separate columns. Okay, and so when we run that code, hopefully you're seeing something along these lines. And we have the 2 different columns here. So that's what that by argument is helping us create. So this is a pretty decent table to start, but notice there are a few things about the table that we might still want to change. For example, the row labels in this table are taken from the variable names in the data frame. So they're lowercase and they don't use white space like we might like. For example, diagnosis.type. It would be much nicer if we had a space between diagnosis and type and we could capitalize in the way that we would like. There's also no information about significance testing in this table, like there is in the published table. So that's something we might like to add. Okay, so and also just a little aside here, if you'd like to save a little bit of typing, one thing that we can do is just save this first part of the code as table data. And this way we don't have to constantly be retyping the select statement over and over. Okay, so the next thing we'll do is add the p-values to the tables. So this is pretty straightforward. We just add this last step to our table summary code and with the function add_p. And when we run this code, we see that this is definitely an improvement. But if you look really closely, you might notice that the p-values here do not match the published table. And the footnote in the table explains why. So if we scroll down in the table, we can get to the footnote. And it says that this table is using the Wilcoxon rank sum test, Pearson chi-square test, and Fisher's exact test to get p-values. And so the help documentation, !add_p table summary, this will explain a little bit more thoroughly about the different types of p-values. So the tests default to Kruskal test for continuous variables. And it has some details here. Wilcox test when by variable has 2 levels, or chi-square test no correct for categorical variables with all expected cell counts greater than 5, and Fisher's test for categorical variables with any expected cell count less than 5. So of course it would be nice if the published table included a footnote explaining what test they used, but unfortunately it does not. We can guess that it was a standard t-test probably rather than the Wilcoxon rank sum test though. So we can control which test GT summary uses by adding a test argument to the add p command. We'll also have it round the p-values to 2 digits instead of 1 by modifying the p-value function command. So we'll see that in a second. Okay, so here's some code that can help us customize our p-values. So here we're going to make the p-values round to 2 digits instead of 1. And we're also going to use t.test instead of Wilcoxon rank sum test. And now when we rerun our code, we can see that the p-values in the table have changed. And if we scroll now back to the footnote of the table, we can see that now we're using the t-test instead of the Wilcoxon rank sum test. Okay, and here we just want to add a little some words of encouragement. So if you're feeling like these arguments look confusing, why do we see one that starts with list? What does that tilde mean? You're definitely not alone. As you get further away from the default settings in GT Summary and also in many other R packages, your code is likely to become less intuitive and harder to read, but that's okay. Because pretty much no one, not even an R expert, would be able to guess how to specify these arguments without looking it up first. So the normal kind of expected process for something like this is to search for what you want to do online, maybe Googling GT summary round p-value to 2 digits, or look into the help documentation until you find example code that does what you need and then copy that code. So part of why we included these examples here was that you can come back and copy them later when you're making your own tables. Okay, so what was that error? When you ran the above code, you might have noticed that R printed out several warnings with text like this. Warning for variable race, simple warning, and stats chi-square test. So like many warnings in R and other programming language, the text of the warning is sometimes, unfortunately, not super clear. But this text does at least let you know what variable had a problem. In this case, it was race. and that it had something to do with the chi-square test we're running on it to get the p-values. And so we won't get into all of the details today, but the reason that this warning is coming up is because it's actually a bad idea statistically to run an uncorrected chi-square test on variables where the expected counts are too low, as is the situation for several of the variables in this table, including race. So today we're just trying to replicate the tests that were done in order to get the published version of the table. But R is right in that we're not using the best choice of tests here. Okay, so one thing that's still kind of outstanding is the labels, the row labels. We really don't want to have labels like prior.chemo_groups in our final table. So we can clean up those labels using the label argument in the table summary command. So this is the code here to do that. So now our table is going to start to look a lot like a published paper. And there are still some things that we might want to change. For example, maybe our table prints out the median with IQR and the published paper prints out the median with range. But this shows what the process is like for building a table with GT summary. And here's the table below. Okay, another thing we might want to do is be able to export a table from R to Word. So to do this, we can save the table as a Word doc, which we can then open and copy into our article. So to save the table as a Word file, we can add the following 2 lines to the end of our table commands. So one thing to point out is that this is going to require a function from the flex table package. And if you've never used flex table before, you may need to run install.packages flex table before the code will work. However, if we want to save, export the table above, this is how we could do it. And by default, flex table is going to save the table in your current working directory. But if you'd like to save it somewhere else, you can use the path argument to specify which folder to save it in. Okay, and here's a little bit more information about how to specify a path if you're interested. Okay, and so our final coding challenge would be returning to RStudio and following the instructions there to create a table 1 for a brand new data set, the laryngoscope data. And here is the published table you'll be trying to recreate. So when you're working through this challenge, definitely have fun and don't worry about getting everything perfect. If you get stuck on part of the table, just move on and try something else. And the goal is really just to get some practice using the GT summary commands. And if you're interested in some more inspiration or looking for other things to try, you can check out this table summary help documentation for more info. And finally, just a little announcement, definitely don't struggle in silence. If you're having questions, reach out, ask questions, and share tips on the CHOP R Slack. You can also come to our office hours to show off your progress or get help. And there are solutions available. So just like we mentioned for coding challenges 1 and 2, there is a solution file in summary stats solution, just the exact same folder where you found the exercises file. But we would really encourage you to try it yourself first before looking at those solutions. And okay, so just a summary of what we covered today. So we looked at getting some example data from the medical data package. We looked at using the summary function. In addition, we used min, max, mean, median, variance, standard deviation, and quantile functions as well. We also looked at the table function and the crosstabs function. And we worked on building tables with GT Summary package, specifically using table summary. And then we also looked at a bunch of different extras throughout on data transformation and data cleaning. And so this was definitely a lot. And so don't expect to remember everything. You have these slides and all of the example code to go back to. And so for the goal was really to come away with a general impression of how to go about getting summary stats in R, and to know that there's some code for you to copy if you want to make a table one. And so here are some more resources for some general background on statistics, and more on the GT summary package is available here as well. Okay, and before we wrap up today, I'll just end with some shameless plugs. So if you wanted to go through this material again, it's also posted as an interactive tutorial online as part of the DART Data and Analytics for Research Training website. So feel free to check out these links. You can also explore the rest of the DART modules with their new module discovery app prototype, which is also linked here. And then our second shameless plug will just say that if all of this is feeling a little overwhelming and you have funding for your research project and you're interested in working with an experienced biostatistician or data scientist to analyze your data and help you create all of your tables, a great option for you might be the Data Science and Biostatistics Unit, which is DBHI and CHOP Research Institute's centralized service unit for biostatistics and data science analysis support. So feel free to reach out to myself or to Keith, one of my other co-managers, if you're interested in learning more about our services. And I think that's it. So I think since we only have 5 minutes left, I won't get into the solutions for today, but yeah, definitely feel free to take a look at the solutions that are posted and reach out to one of us or join the CHOP office hours if you have questions about the solutions. But yeah, maybe we can stop and see if there are any quick questions. Otherwise, thanks so much for coming today.